Okay guys, our next topic is relation between alpha, beta and gamma. Now what is alpha? Alpha is basically the amplification factor or current gain in common base configuration. Okay, so alpha can be written in two forms. One is alpha DC, which is the static value of alpha, and the other one is alpha AC, which is the dynamic value of alpha. We can say it as a change in values. So alpha can be written in two forms. One is alpha DC, okay, which is output current or input current in common base configuration. Output current in common base configuration is IC and the input current is IE. This is the value of IDC. Similarly, the alpha AC, like the dynamic value of alpha is change in output current or change in input current, while keeping the output voltage, which is VCB in common base configuration, is constant. Now similarly, beta is the current gain in common emitter configuration, or we can also call it as the current amplification factor in common emitter configuration. So we can also write beta in two forms. One is beta DC and the second one is beta AC. This is beta DC, which is the static value of beta, which is equal to the output current in common emitter configuration, which is IC, or the input current in common emitter configuration, which is IB. Similarly, the beta AC value, like the dynamic value of this current amplification factor in common emitter configuration, is change in output current, which is delta IC, or change in input current, which is delta IB, while keeping the output voltage, which is VCE, is equal to constant. Now similarly, gamma is the current amplification factor in common collector configuration. So it means that gamma can also be written in two forms. One is gamma DC, which is the static value of gamma, which is equal to the output current, which is IE, over input current, which is IB. And similarly, the AC value of this gamma, the dynamic value of this current amplification factor in common collector configuration, is change in output current, which is delta E, or change in input current, which is delta IB, while keeping the output voltage, which is VEC, as constant. So these are the definition of this alpha, beta and gamma, because we already defined it before. So here I just repeat the older concept. Now we know that the emitter current is related to the base and collector current by this relation. Like emitter current, which is IE, is related to the collector current IC plus I by this relation. Now, next I have to divide this equation throughout by IB, the base current. And if you divide this equation throughout by IB, then I have IC or IB. Oh, sorry, IC or IB, IE or IB. Sorry, this is the emitter current. Yes, which is equal to IC over IB plus IB over I. Now this is equal to IE over IB, which is equal to IC over IB plus 1. Now if we look at this equation, IE is the output current in common collector configuration, and IB is the input current in common collector configuration. So this factor IE over IB is equal to the current amplification factor in common collector configuration, which is represented by gamma. So this term is equal to gamma. Similarly, here IC is the output current in common emitter configuration, and IB is the input current in common emitter configuration. So their ratio will give us the amplification factor, current amplification factor, current gain in common emitter configuration, which is represented by beta plus 1. So gamma is equal to beta plus 1 is one of the relation. Gamma is related with beta by this relation. Now we know that I call this is equation number 1, okay, and this is equation number 2. Now we know that beta is related with alpha by this relation. Beta is equal to alpha over 1 minus alpha. Let's say this is equation number 3. So using equation 3 into, we have, if I put equation number 3 in 2, we have gamma is equal to beta, which is alpha over 1 minus alpha plus 1. So gamma is equal to alpha, so 1 minus alpha is taken as LCM. So here I have alpha, and then here I have plus 1 minus alpha. So alpha cancel with this alpha. So gamma is equal to 1 over 1 minus alpha. This is equation number, let's say. Now if I look at equation number 2 and equation number 3, then equation number 3 and 4, no sorry, equation number 2 and 4, then here gamma is equal to beta plus 1, and also gamma is equal to 1 over 1 minus alpha. So it means that beta plus 1 is also equal to 1 over 1 minus alpha. So I can write gamma is equal to beta plus 1, okay, but gamma is also equal to 1 over 1 minus alpha, 1 over 1 minus. So this is basically the relation between, this is equation number, let's say 5. So equation 5 shows the relation between gamma, beta and alpha. So the gamma, beta and alpha are related with each other by this equation, like gamma is equal to beta plus 1, or gamma is equal to 1 over 1 minus alpha, or beta plus 1 is equal to 1 over 1 minus alpha. Or we can also say that beta is equal to alpha over 1 minus alpha, because both the things are the same, because beta plus 1 is equal to 1 minus alpha. So beta is equal to 1 over 1 minus alpha minus 1. So if I simplify it, then I get beta is equal to, so this implies that beta is equal to alpha over 1 minus alpha. So again I have this. So this relation can be deduced from this one. So this is all about the relationship between alpha, beta and gamma. Thank you.